In this video, I will discuss some NEET PYQs from the topic Mechanical Properties of Solids. These questions are based on Young's modulus of elasticity and bulk modulus of elasticity. I will discuss some 5 questions. This is the first one. The following 4 wires are made of same material. Which of these will have largest extension when same tension is applied? So different wires, material is same, length is different, and diameter is different. That the cross-section area is different. You can pause and run this question. So Young's modulus is defined as stress by strain. So stress is change in the length by original length. Stress by strain. Stress is the force or the tension applied per unit area by strain delta L by L. So to find the largest extension, which is largest delta L. So delta L is T by AY into L. L will go up, delta L will come on this side, Y will come down. So obviously delta L is more if L is more, and if the tension is more, delta L will more. So you have to compare this value for all the 4 cases. Tension is same and Young's modulus is same. Tension is same because it's given in the question, and Young's modulus is same because it is the same material. Young's modulus is a material property. Since the material is same, this thing is same. So basically you have to compare L by A of these 4 cases. And what they are given is a diameter. So you have to compare L by D square of all the 4 cases. So the first one, L is 100 and D square is 1 square. This you have to compare with the second case. L is 200 and the second case diameter is 2. And the third case, 300 length and the diameter square is 3 square. And in the fourth case, the length is 50 all centimeters and the diameter is 0.5 square. So the dimension of each or the unit of each of this quantity is centimeter by mm square, because length is centimeter, diameter is mm. You don't have to convert this to centimeter because all the dimensions are same and you have to compare their values. So the first one is 100 and the second one is 200 will become 100 by 2. 200 can be written as 100 into 2 and 1 2 will cancel here, so it will become 100 by 2. 300 can be written, or 1 3 can be cancelled here, it will become 100 by 3. 1 2 will cancel here, it will become 100 by 2. 1 3 will cancel here, it will become 100 by 3. And the last one is 50. 0.5 square is 0.25. And this is into 4, so this will become 200. So 100, 50, 100 by 3, 200. So this is the maximum value. So largest extension is the last case. D is the correct answer. So Young's model is given as stress by strain. Stress is force per unit area, where the force is tension in the wire, and area is pi by 4 d square. Area of a circle is, or a disc is, pi r square. In terms of diameter, it will be pi by 4 d square. You can remember this formula. Strain is the change in length by original length. So from this, I get delta L as proportional to L by d square, because tension is same for all the 4 cases and y is also same. So to compare delta L, we have to compare L by d square. Delta L taken on the right side, y is a constant. So you just have to compare d L by d square. L will go up, d square is there in the denominator. So to compare L by d square for the 4 cases. First one, L is 100 centimeter and diameter is 1 mm. So the unit of all these quantities will be centimeter by mm square. There is no need to convert because you just have to compare. So the conversion factor will get cancelled. So you don't have to waste time in converting the units. Second one, 200 by 2 square. So this one, if you compare, you get the option D as the largest extension. This is the next question. The ratio of diameters and lengths and Young's modulus of steel and copper wire shown in the figure are PQ and S respectively. Then the corresponding ratio of increase in their lengths would be. 4 options are given. So there is a steel wire, there is a mass of value 2m, and there is a copper wire and mass is 5m is attached here. So obviously this wire will get stretched and this wire will get stretched. So you have to find the ratio of the increase in the length of this one and this one. You can pause and attempt this question. So Young's modulus of steel is stress by strain. So the force which is stretching this wire is this mass and also this mass, because this mass is pulling this wire, which will pull this full thing down. So the load on the steel wire is 2m plus 5m. We can neglect the mass of this copper wire, which is usually small. So the total load that's acting on the steel wire is 7m. If that is the mass, then it is the weight mg. That is the force divided by the cross-section area of the steel wire. Divided by strain, which is elongation of the delta L, I can call it as E also, elongation, divided by the length of the steel wire. And Young's modulus of copper. The load that's acting on this copper is 5m. This will just provide the support. The load acting on only this mass 5m, which is pulling it down. So 5, its weight mg divided by the area of this copper wire, elongation of the copper wire by the length of the copper wire. So to find the ratio of the lengths, you have to find ES by EC. So from this, I'll get ES as, okay, ES will go on the right this side, similarly EC will go on this side. So after taking this, if I divide this, I'll get ES by EC as mg will cancel. So 1 by 2, because ES will go here. So 7 by 5 into AC by area of steel, and then this LS will go at the top, LS by LC. Just check. ES will come here on the right side and YS will come down. So into YC by YS. YS is coming down, so it's down. So this is dividing, so it will go up. 7 by 5. This divided by this. After taking this thing on this side and this thing, bring this thing down. So take this thing EC here and bring YC down and then divide. So this will give me 7 by 5. The ratio of the diameters. So this in terms of diameter will be, diameter is 5/4 d square. This will become diameter of copper by diameter of steel square. So ratio of diameters is P, and that is steel by copper. So steel is down, so it will become 1 by P. First by second, steel by copper is P. And this one, length of steel by copper, length ratio is Q. And steel is the first one, so it's Q. And the next one is steel, it's A, so 1 by S. Because this ratio is steel by copper, steel is down, so it will become 1 by S. So this is 7 by 5 Q by P square S. So 7 by 5 Q by P square. C is the correct answer. Next model of steel is stress by strain. Stress is the total load 7 mg acting on this. So 7 mg by A1, and then strain is E1 by L1. E1 is elongation. So from this I'll get E1 as 7m by A1 into Ys. L1 will come here. Similar elongation to looking at this, you can write instead of 7 will be 5m because the load is 5m, and instead of L1 will be L2 and E2 by Yc. So E1 by E2, divide this thing and the given ratios, we get option as C. Next question. Two wires A and B of same material, their lengths in the ratio 1:2, diameter in the ratio 2:1. If it is pulled by the same force, then the increase in the length will be in the ratio. This is similar to the previous question. Instead of P, Q, and S, they are given the numbers here. You can pause and attempt it. So two wires of the same material, so Young's model is the same. Okay, previously the Young's model was different. Here Young's model is the same.